All right, not much new in 6-5 day 2. Just a little practice. I actually only have 3 examples for you. So it's good, just some extra practice with everything we've been doing. So 6-5 day 2. And we're going right into examples. Sine x raised to the cosecant x. So again, get used to noticing the x in the exponent. You can't do derivative until it's down. So let's log both sides to knock it down. Okay, now that it's the exponent on a log, it can come down out in front as a multiplier. So ln y cosecant x times the ln of sine x. Ready for derivative? 1 over y prime. Here, notice x term times x term. Do not just do derivative times derivative. This follows product rule. So here we go. U prime. Derivative of cosecant is a negative cosecant cotangent. Derivative of the angle's 1 multiplied by the v plus, I'm going to keep the u, times, derivative here is 1 over sine x, times by the derivative of that, which is cosine x. So we are just about ready. Cosecant times cotangent, let's see, that's 1 over sine. Cosine over sine, nothing cancels, so I'm going to leave it. Just checking for any simplification. Over here, if you remember, cosine over sine does turn into cotangent. Cosecant will be 1 over sine. Nothing cancels, but I can take these two terms and make that cotangent. Oh, I forgot my 1 over y here. And now my last step is to multiply both sides by y and substitute what y is for. So I'm going to times by y here, put parentheses, times by y here, and then substitute that in for the y. So, oops, put that in the wrong spot. Negative cosecant cotangent, ln of sine, plus cosecant cotangent, oops, all times sine raised to the cosecant. Oh, just fit. And could I basket factor out a cosecant cotangent? Yes, but it doesn't really do me any good. Nothing happens there, so leaving it alone. All right, next one's going to be done a new way. So number 2. Y equals 4x plus 9 raised to the 5th, and then 3x minus 7 raised to the 4th. Now, if you remember these were when we learned product rule, these were the really long ones that had the basket factoring and all the simplifying. It took a lot. Well, even though there's not an x up in the exponent, so we do have a way to get that derivative. But because there is an exponent here, if we try this, hit both sides with the log thing, it does simplify things quite a bit. So we're going to do it with using natural log first. So we're going to log both sides. So before we bring exponents down, we have to get them as separate terms. So we're going to use the log of a product and expand it to the sum of the two logs. So we're going to keep this side the same. It's like distributing, but putting an add between them. So it's the ln of 4x plus 9 to the 5th plus the ln of 3x minus 7 to the 4th. And now I'm going to take the time to bring the exponents down. I know some of you will be skipping that step I just wrote, and that's fine. I just don't like to lose anybody. So now the 5 comes down. ln of 4x plus 9. Now the 4 comes down. ln of 3x minus 7. And now it's derivative ready. So this is 1 over y prime. Here we keep the 5 multiplier and we do the derivative of the natural log. So it's 1 over 4x plus 9 times by a 4. So that's going to be a 20 numerator. Here I keep the 4 times by that derivative, 1 over 3x minus 7 times by the derivative, which is 3. And now multiply both sides by y. So times by y times by y. We'll have 20 over 4x plus 9 plus 12 over 3x minus 7 all times 4x plus 9, y equals, if I go back to the original, y equals this whole thing here. 4x plus 9 to the 5th and 3x minus 7 to the 4th. And there we go. And we could get a common denominator here and bring them together, but the author does not. So we're not either. So that's going to be our final. And we're going to do one 2 ways and show that they are the same. We're not doing this one 2 ways because that's obnoxious. Maybe in the homework. Save that one. So number 3. We got y equals x cubed. We want to do it 2 ways and show that they're equal. Show equal. So the first way is just to leave it like it is. We know how to do the derivative of that. So here, y prime equals 3x squared. The second way is to hit both sides with a log. Not that we would have to, because we got this simple derivative, but I just want to show you that that natural log technique will always work. So the second technique is hit it with a log on both sides. So ln of y equals ln of x cubed. Right from the y equals x cubed equation. And we better write that down. Now we're ready for derivative. 1 over y prime, 1 over x cubed, and then times 3x squared. So we'll cancel an x squared. So we have 1 over y prime equals 3 over x. And now I've got to multiply both sides by y. Cancel there. Now I have to substitute because I can't have x's and y's, so I keep the 3 over x. And I replace the y with y equals x cubed. I can cancel one x here. And lo and behold, the natural log way works, but it was longer. But they are the same. Author's real big on those, show that they're the same problems. Okay, that's all there is. 10 and a half short minutes. It's a good day.